Today we're going to talk about how to name straight chain organic molecules. We'll talk about branching chains in another video. The first thing you need to look at is your carbon-carbon bonds between the carbons. Make sure that they're all single bonds. If they are, then the name is going to end in A-N-E, because these are classified as alkanes. All single carbon-carbon bonds. Notice it's just a hydrocarbon. It has hydrogen and carbon, nothing else. When you put other side groups on there, it will change the names. If we look at this molecule that we have here, we want to count the number of carbons. So we have 1, 2, 3, 4, 5 carbons. So we go down our chart here, 5 carbons. Our prefix is pent. And then since it's all single bonds, our ending is ane. So this molecule is pentane. Written out like this is called a structural formula. If we wrote the chemical formula for it, it would just be C5H12. 5, 10, 11, 12. When you look at these molecules, you're always going to have this situation where you take the number of carbons times 2 plus 2. So if we have carbon, n number of carbons, your hydrogens will be times 2 plus 2. So for example, if we had an alkane with 7 carbons, our hydrogens would be 2 times 7 is 14, plus 2, 16 hydrogens. And that's called the chemical formula. There's a shorter way of writing these. Instead of writing out all the hydrogens like that, you can also write it with the carbons. Always show the carbons. But the hydrogens, you can just show the bonds for where those would attach. So those two models are equivalent. They're both structural models. So let's try naming some more. In the upper left, we have 3 carbons. If we go to our chart, 3 is prop. They're all single bonds. So this would be propane. That's the stuff you have in propane tanks that you attach to grills and cook your meat with. And then this other one at the top, 2 carbons. So we go to 2 is F. Single bond in between, A-N-E, ethane. Bottom left, 4 carbons, all single bonds. 4 carbons is bute. So this is bute, and then A-N-E, butane. That's the stuff that you have in lighters. This next one's a little tricky because we haven't talked about ring structures, but they're pretty straightforward. So it doesn't matter where you start since it's all symmetrical, but count your number of carbons. So if I start here, I have 1, 2, 3, 4, 5, 6 carbons. We know that 6 is hex, but we need to indicate that it's in a ring. And to do that, we use the prefix cyclo. So this is cyclohex, and they're all single bonds around the ring. So cyclohexane. So now you may be wondering, well, what other kinds are there? What if they're not all single bonds between the carbons? So let's look at those. And each carbon should always have 4 bonds to it. Now this one already has 1, 2, 3, so I'm only going to put 1 hydrogen on that one. This one has 1, 2, 3, so I'm going to put 1 hydrogen on that It doesn't matter at this point if they're going up or down for beginning chemistry. It does matter later. So we notice here we have a double bond. And when you have a double bond somewhere in your chain, you use the ending ENE because it is an alkene. It's a class of hydrocarbons that contain a double bond. So again, we count our number of carbons. We have 1, 2, 3, 4, 5, 6, 7. If we look at our chart here, 7 is hept. A lot of my students want to put sept because they're taking a foreign language, and maybe 7, maybe in Latin or something, 7 starts with an S. Notice there are none of them start with S's. So just take the S's right out of your vocabulary for this, and it's hept, H-E-P-T. It's going to be hept because it has 7 carbons. We have a double bond, so we want the ending E-N-E, but we're not finished because that double bond is between the 1, 2, 3, and 4 carbon. If we had it between, say, the first and second carbon and still had 7, 1, 2, 3, 4, 5, 6, 7, that would also be heptene. Well, we can't have 2 different structures with the same name. We use a number to indicate the location of that double bond. Since this one at the top is between carbon 3 and 4, you use the smaller of the number. Count from both sides, make sure you get the smallest one. If I count from this end, it's between 3 and 4. If I count from this end, it's between 4 and 5. So this has to be carbon 1 here. 1, 2, 3 indicates that this ene, this double bond, is between carbon 3 and 4. This one is between carbon 1 and 2, so this would be heptene. 1 heptene, because it's between 1 and 2. Number in front is the location of ENE double bond. What do we do with a triple bond? So a triple bond is going to look like 3 dashes. This one already has 4 because that counts as 3, and there's your 4th. So we're not going to put any more hydrogens on that one. A triple bond belongs to a class of chemicals called alkynes. Y-N-E. So our ending is going to be Y-N-E for these to indicate that there's a triple bond. So there are 4 carbons. 4 is bute. It has a triple bond, so our ending is Y-N-E. And the location, whenever this is not an A-N-E, you have to put a location in front. It's between carbon 1 and 2, so this would be 1-butyne. Let's practice a few. All right, so pause the video, see if you can come up with the answers, and then hit play to check. Our first one has 4 carbons, so it's bute. It has a double bond, so it's E-N-E. And the double bond is between carbon 2 and 3, so it is 2-butene. Our next one has 1, 2, 3, 4, 5, 6. 6 is hex. It's got a double bond, so E-N-E. And whenever this is not, whenever you have a double or triple bond, you have to say what the location is and put that in front. So 1, 2, 3, it's between carbon 2 and 3. So we call it 2-hexene. Next one has 5 carbons in a ring. Ring is cyclo. 5 is pent. And all single bonds, so A-N-E for single bonds. Our next one is 1, 2, 3, 4, 5, 6, 7, 8, which is oct. We have a triple bond, which is YNE. Now, don't be tricked. If I count from this end, if I make this carbon 1, 2, 3, 4, 5, 6, 7, it would be 6-octene. But that is incorrect, because if I count from the other end, 1, 2, 3, it's between 2 and 3. So this is actually 2-octene. But you need to always, with a situation like this, start counting from the end closest to your multiple bond. I hope this has helped. And check out other videos that I might have that may help you. I will do a future one where I talk about branching hydrocarbon chains and how to name those. Have a great day.